typical definition for continuity or if a function is continuous is by saying a function is continuous at number A if the limit of the function as x approaches A is equal to the function.
That's right. My bad.
Thank you. Okay, so if the limit is the same as the function is evaluated at that point, then we have a continuous function. This implies these two things. If a function is continuous, then f at A is defined and A is in the domain. It exists at that point. We can also say that the limit exists at that point from the left hand side. Limit is at the closest A of x exists. Finally, that the limit as x approaches A is equal to the function f. So let's take a look at some examples of functions that we've seen before that we're going to encounter. In order for a function to be continuous, we say this is kind of the summary of the entire lesson. We must be able to draw it without lifting the pencil off. No holes and no breaks. The function is discontinuous if there are holes and breaks. So in our first picture, I can draw and trace the whole thing. On the second picture, I can draw the left side and I can draw the right side. So I need to pick up my pencil when I hit the vertical opposite. Okay, so this one, because we have an infinity here, this is discontinuous. Because we encountered this position. In the next picture, we have a jump. Up here. So here we have a jump. You can call it this. So essentially the left hand limit this and the right hand limit is this. So do not equal. The function is this. The domain is all zero. So 2 out of the 3 conditions are met. Function exists, A is in the domain, the left hand and the right hand limits exist, but the left and right don't equal, and they don't equal the value of the function at that point. Okay, and finally here, have what we call a removable. Okay, so here the left hand limit exists, the right hand limit exists, they do equal each other, so the overall limit exists. F is defined at that point. However, the limit and the function not agree on this. The function says that the value is here, but the limit says limit as x approaches c is down here, but the point of f is c. The limit is the function is in the domain. But the limit. Okay, so these are the 4 types of things we're going to encounter. An infinite discontinuity, a jump discontinuity, or a removal. So for the following, which of the ones are discontinuous, or where are they discontinuous? So let's take a look here. We have a function. I can see that I have a non-permissible value where x equals 2, I need to decide, is this an asymptote, is this a jump, or is this a shift? The way that I'm going to do that is by find the factor and see if I can calculate. So looking at the top, I have x squared minus x 2. That is a trinomial, it's a quadratic, so I should be able to factor it minus 1 on the top. Okay, because I have a common factor here, this is going to be a removable continuity. Because technically I can factor it out, but the fact that I can factor it out tells me I have a whole because it is certain to okay? So if I were to demonstrate with this picture, the limit of x is closest out of the function x plus 1. Because this two direct substitution as x is closest to the limit should be. So this looks like essentially a line with a y-intercept at 9, but a whole the limit of this, I can essentially draw a picture. I know where the hole is. That's 2, 3. The limit of this, the function is there, but we have a limit of this. The domain of this function. So if you can factor it out, you have a removable discontinuity because you're removing this discontinuity. Still exists, but can be removed. On the other hand, let's take a look at this one. Okay, if the function is anything except 0, then I follow the 1 over x squared. Remember that when we did 1 over x, it's like this. 1 over x squared is essentially the positive of this. So this slightly darker story, which is essentially it looks like this, where we know that these endpoints go off to infinity as they approach 0, and then it says if the function is x equals 0, then I have a clue of x. So in this function, I have a domain of x is all. However, if I look at what happens to the limit as we approach 0, the limit goes to 0, I have to look at the function of 1 over x. Because I'm not looking at x0, I'm looking at around 0. So around 0, the function is 1 over x squared. So we have the left hand limit, right hand limit, they're both going off the positive integral, but they do not. So the function is 1, but they really. Okay, I'm going to ask you to pause for just a moment here. Bearing this in mind, I want you to try some homework questions. Page 133, number 3 and 6. So just take a minute to use this one and do that.